Looking out at the universe today, it's easy to be absolutely awed by all that we can find. The stars in our night sky are just a tiny fraction, a few thousand out of hundreds of billions of what's present in our Milky Way. The Milky Way itself is just one lonesome galaxy out of trillions present within the observable universe, which extends in all directions for some 46 billion light-years. And it all began some 13.8 billion years ago from a hot, dense, rapidly expanding state known as the Big Bang. And it's all still expanding, forming new stars and evolving. For a long time, scientists who studied the structure and evolution of the universe considered 5 possibilities about how the universe could end. So let's discuss about the leading hypotheses about how the universe could end. Number 1. Heat death of the universe or Big Freeze. Just a couple trillion years from now, because of dark energy, the universe will have expanded so much that no distant galaxies will be visible. From our own Milky Way, all star formation will cease too. Stellar remnants will fall apart. In fact, black holes will be the last surviving sentinels of the universe as we know it. But eventually, even these black holes will disappear too, as Stephen Hawking predicted that black holes slowly evaporate by releasing their particles into the universe. No normal matter will remain in the universe, and the second law of thermodynamics tells us that in this time frame, all energy will ultimately be evenly distributed. The cosmos will settle at its final resting temperature, just above absolute zero, the coldest temperature possible. According to scientists, calculations suggest that it will be a slow death that's drawn out for a googol years. 1 googol years is a 1 followed by 100 zeros. The universe will cool as it expands, eventually becoming too cold to sustain life. Number 2. The Big Rip. A similar scenario leads to a far more dramatic death, much sooner. In this model, dark energy doesn't just accelerate the expansion of the universe at a steady pace, but it accelerates so much faster by tearing the very fabric of reality apart, an ending called the Big Rip. In the Big Rip model, the exponentially accelerating expansion pushes more and more objects beyond boundary of the observable universe. Any 2 objects that are farther apart than this boundary can no longer influence each other through the fundamental forces like gravity or electromagnetism. As that distance, large-scale structures of the universe will begin to crumble as gravity's influence shrinks. It won't be able to hold galaxy clusters together and they'll start dissolving. Eventually, the same will happen to the galaxies themselves, sending stars drifting off on their own. Later, the cosmic event horizon will shrink beyond the scale of an individual star system, meaning planets will no longer be bound to their orbits around stars. And finally, atoms themselves would be ripped apart, particle by particle. The last victim is the fabric of spacetime itself. The scientists who proposed this model predict that, if it were to happen, the universe has about 22 billion years left to live. Number 3. The Big Crunch. Perhaps the universe will end in the exact opposite way. Instead of expanding forever into nothingness, it changes and collapses in on itself in a so-called Big Crunch. If the density of matter in the universe is high enough, its gravity could overcome the expansion and trigger a contraction phase instead. Everything will begin to move towards everything else as the universe shrinks once again. Galaxy clusters would start to merge, then galaxies themselves and eventually individual stars would collide more regularly. The temperature of the universe would be so extremely hot that atoms themselves fall apart. And they'll be sucked into the black holes that are taking up an increasing percentage of the shrinking universe. Eventually, the entire contents of the universe will be crushed together into an impossibly tiny space, a singularity, like a reverse Big Bang. Number 4. The Big Bounce. A variation on the above hypothesis suggests that moments before the universe collapses into an infinitely dense singularity, it's saved by quantum processes and reverses once again, beginning a new period of expansion that's effectively another Big Bang for a brand new universe. This model is known as the Big Bounce. While it might sound a little too convenient, proponents of the idea say that There is some precedent in the world of quantum physics after all. As the universe shrinks towards a singularity, it becomes so small that quantum rules take over from the large-scale classical physics we're familiar with. At that point, quantum tunneling can occur, where particles can overcome barriers that, by all accounts, they shouldn't have enough energy to pass through. The Big Bang's hypothesis is that we might be in the middle of a never-ending chain of universes being created and destroyed. Number 5. The Big Slurp. The Big Slurp is the most unsettling because it could already be barreling down on us and we wouldn't know until it hit. It's called a false vacuum decay. All known quantum fields are in their stable vacuum states except the Higgs field. It seems to be in a false vacuum state, which means that it currently appears stable, but is predicted to not be in its lowest energy state. But that could change without warning. Literally any second, the Higgs field could suddenly slip into a lower energy state, which would send a bubble of vacuum decay expanding outwards at the speed of light. Moving that fast, we couldn't even see it coming until the wall of that bubble slammed into Earth. What happens once we're inside this bubble? No one's really sure, but it will probably rewrite the laws of nature. Although we do not know which of these possibilities is true for our universe. Until then, all we have are the possibilities we know to consider. The rest is up to science. Thanks for watching my video. Please like, comment and share this video. Don't forget to subscribe my channel for more space videos.